This is my Physics 2212, Lab 3, Magnetic Field of a Permanent Dipole Magnet. So this lab uses the concepts of permanent magnetic dipoles, Biot-Savart's law, and Earth's magnetic field in order to find the distance dependence of a bar magnet compared to the predicted distance dependence. The fundamental physics at play here is the magnitude of B bar equals KRN, where R is the distance away from the magnet and N is the distance dependence. We can also turn this equation into linear one so that we are able to graph it using our data and then find K from that. And then we are also going to be able to set B bar equal to B using the standard equation of a magnetic dipole. Our magnetic constant is also 1 times 10 to the negative 7th. The experimental setup, I set up a piece of tape outside away from any metal or magnet in order to get as much of an accurate reading as possible. Set the magnet up on one end, measured out some measurements on a piece of tape in centimeters, and then used my phone as the magnometer in this experiment. I slid my phone to the left and right for the first part of the experiment, and then I did left and right and up and down for the second part of the experiment so that I could get a reading on D perp, which is going to be what we use to find the distance dependence. So when the magnometer is far away from the magnet, it measures the near zero magnetic field in the x direction. That's because we adjusted this lab setup in order to account for the Earth's normal magnetic field, and we set that up by having the magnetic field run in the y direction of our magnometer, meaning that we had zero interference on the x direction when it came to the Earth's magnetic field. And then as the magnometer moves closer to the magnet, the measured x component of the magnetic field increased. So here's my lab results. Overall, this is the equation we got here in the center here, and that allowed us to find K, which we will reveal on the next slide. And then we also got a B net, which will be important later, of 0.000046996. which is the magnitude of our expected dipole movement due to the distance, due to the x and y components of the second part of the experiment. So the value of K is 4.06 times e to the negative fifth. The value of N is 3.011, which was approximately 3, so we can assume N is 3. In doing that, we can set B bar equal to B, which is going to give us the magnitude of mu, which is 3.79. We're going to plug that mu of 3.79 into our GlowScript code right over into our GlowScript code at the top, and then we're going to be able to use that in order to find the magnetic field on the axis, the magnetic field perpendicular to the axis, and then the magnetic field 45 degrees from the axis, as shown in that last experiment. So here's our results. If you notice, the B at the 45 degree at distance D is going to produce a magnitude that we predicted, or close enough to what we predicted, so our model is as accurate as possible, which is good. And so, lab report questions. What if you haven't oriented the experiment to compensate for the magnetic north, and instead laid out the meter stick to some intermediate angle with respect to the Earth's magnetic field? So if the experiment was not oriented to the respect to the magnetic north, then our x measurements would be off due to the degree of the magnetic field of the Earth. So by turning it towards north, we're able to get results that do not require additional calculations, as well as being able to check and calibrate the system over time in the experiment. There was multiple times where I accidentally bumped my iPhone or moved a piece of tape, and I was able to recalibrate my experiment due to the fact that we had a constant 0 in the x direction due to the calculation of Earth's magnetic field into our magnometer. And last but not least, what if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? We would expect the results of the distances to be greater, since the two magnets working together as one magnet would make it a much stronger electric field. But it would not double it, it would be some ratio in between that. Thank you very much for your time.